Hi everyone. So one of you asked me to do a question from the worksheet on tension, question number 4. So question number 4 says repeat question number 3 with the coefficient of friction between the two blocks. And the surface is 0.21. So basically, really you had to do question 3 again, but now we're adding friction. So we have these two blocks tied together, and then there is the force applied of 20 newtons pulling them to the right. So this is, you can call this your FA here. Okay. So what's the acceleration, and then what's the tension? Now the approach is going to be first to find the acceleration of the system. So we need to include all the forces acting on this. So in this case, the two blocks are being dragged on some surface here, right? So we're going to have friction in this case in question 4. So if we are resting the blocks on a surface, means we're going to have a normal force. So let's call this our M1, M2. So this is going to be Fn2, Fn1, and then we're also going to have gravity, Fg1, and then we're going to have tension this way, tension that way. This is the, let's change this from T to Fa. That's the force applied. And again, we're adding friction, so we need to add two more vectors here. So we're going to have friction, call this Ff2, force of friction, and this one F of F1. So in this case, we don't know what the force of friction is, but we can find it. So let's write the F net for the system. So I have all the forces labeled. Basically, I just added two more forces. So here we're going to have our sum of forces, our F net for the system. So again, this is sum of forces for the system in the x direction. We will have positive towards the applied side. So we're going to have our force applied, positive. Then we're going to have negative friction, negative tension, positive tension, and then negative friction 1. And all of this is going to equal to m total times the acceleration of the system. So again, the acceleration is going to be the same for all the masses. You can have 100 masses string together. The acceleration of the system will correspond to the acceleration of each of the objects along the x-axis in this case. So the goal is to find this A. Now notice here the tension will cancel out here. So we're left with Fa minus the friction force 2 minus the friction force 1 equal to total mass times A. Again, we're looking for the A. So it's going to be all of this over the total mass, which in this case we only have the two masses, so it's going to be M1 plus M2. So that's our formula. Now we have to figure out what to plug in for each of these. Fa is given, so that's pretty straightforward. We just plug in at 20.0, but the friction forces are not given, so we had to come back and figure out what those friction forces are. We know what the coefficient of friction is. It's 0.21 for both of them. Now we had to basically write the F net for the y direction for each of the masses. So we're going to say M1, we're going to have the sum of forces in the y direction equal to the, let's make it positive up as well. So we're going to have Fn1 minus Fg1, and this is going to equal to 0 because the objects are now moving in the y direction. So our acceleration in the y direction will go to 0, which leaves us with Fn1 equal to Fg1, which will equal to m1 times g. Now, why do we have to do this step? Well, because remember your force of friction, your F friction, is going to equal to mu Fn1. So we need to know what Fn1 is so we can find the force of friction. So we're going to replace this with what we know. So it's going to be mu times m1 times g. So that's our force of friction that's going to be placed into our formula for acceleration of the system. So we're going to do the same thing for mass 2. So we're going to come up with a F net in the y direction, which now we have our Fn2 minus Fg2 equal to ma. Again, in the y direction, this goes to 0. So we get Fn equal to Fg, which equals to m2 times g. So now we could say, therefore, our Ff2 equals to, again, mu Fn2, which is going to be mu m2 times g. So now we're going to take these two. So this is our F1, F of F2. We're going to plug that in here. So let's do that. Let's take our definitions and rewrite this acceleration formula one more time before we plug in any numbers. So notice here we have positive, right? But because of this negative, this becomes negative. So we get Ff2 becomes negative mu m2 times g, negative mu m1 times g. Now here we could factor out the mu and the g from each of these if you want. That's fine if you do that. Just an extra step, or you can just plug in all the numbers after this. So I'm just going to plug in the numbers. So Fa was 20.0. Okay. Our mu is 0.21. 0.21. Our mass 2 is 2.0 times 9.8. Mass 1 is 3.0. Okay, divided by the total mass, which is going to be the sum of 2.0, or 3.0 rather, and the 2.0. So in our numerator, notice here the first multiplication we have to do, we have 2 sig figs times 2 sig figs, so the answer should be 2 sig figs. So we're going to do 0.21 times 2 times 9.8. That's going to be 4.1. Now in this case I did round it, so normally I said don't round it, but because it's 4.11 it wouldn't make a big difference anyway. Or you can keep the extra decimals, just remember it's going to be 1 decimal here because it's going to be 2 sig figs. Looks like we're going to end up with just 1 decimal for all of the numbers in the numerator. So then we have 0.21 times 3 times 9.8. We get 6. Alright, I guess I'll keep the decimals here. But again, I know that this should only be 1 decimal here. 1 decimal, right? So in the numerator, now we have to do subtraction. In the denominator, we can add these two together. Least number of decimals, so it's going to be 5.0. So on the top, we have 20 minus 4.11 minus 6.174. And all of this is going to be 9.7 over 5.0. So we get 1.9 meters per second squared as our acceleration for the system. Right, so that's our acceleration for question 4. Let's see, 1.9, 1.9. So we got that right. So again, the only difference between number 3 and number 4 is that we added the friction force, and because it's not given as a number, you have to calculate it, so you need to write the Fnet for the Y for each of the masses to find the definition for the Fn1, Fn2, and then get your force of friction. The next step is to find the tension, and in this case you can pick any of the masses, either mass 1 or mass 2. Pick the one with the least number of forces acting on it to make it simpler. For example, if you look at M1, you only have tension and force of friction. If you pick M2, you have F applied, you have tension, you have force of friction too. So it's easier to work with the M1. So I'm going to pick my M1 and find tension. So part B, again, pick M1. Here's my free body diagram for M1. We have Fn1, Fg1, tension, and force of friction. Okay. Now we already found what force of friction was from up here, so my Fnet for x direction is just going to be, so let's make it positive this way, is going to be tension minus force of friction equal to m, this is m1, which was 3 kilograms, m1 times the acceleration of the system that we found. So again, all of this is known. We already know this. We know the mass, we know the acceleration. Only tension is unknown. So tension equals to m1, the acceleration of the system, plus the friction force, which is going to be mu m1g. So that goes here. All right, so I moved it to the right, so it becomes positive. So the last step is to just plug in the numbers to get the tension. So M1 was 3.0. Let's double check 3.0. System acceleration is 1.9, 0.21, 3.0 times 9.8. So do the calculation and you get your tension. So 3 times 1.9 is 5.7, so 2 sig figs here. And then we have 0.21 times 3 times 9.8. So again, that's also going to be 2 sig figs, so plus 6.174. But again, this is only 2 sig figs, so it's going to be, when you add them, it's the least number of decimals, so you had to round to 1 decimal when you add it. So this plus 5.7, we get 11.87, so we're going to round it to 11.9. So again, because of 1 decimal here, 1 decimal there, least number of decimals, we had to round this to 1.9 newtons. So that's going to be our tension in the rope between the two masses. Let's double check. 12 newtons. So yeah, I think the answer key is a little off, but well, 11.9 and 12, that'd be 2 sig figs, but because we're adding, we should look at number of decimals. So this is the right answer here. So it should be 11.9, not 12.